Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll find domain and range of a function from its given graph. As you can see, the given graph is in the form of two curves. One curve is in quadrant 1, the other curve is in quadrant 2. This graph has asymptotes. An asymptote is a line that a curve gets very close to but doesn't touch it. In this graph, there are two types of asymptotes, a vertical asymptote and a horizontal asymptote. Let's find the asymptotes in this graph. Let's start with vertical asymptote or VA. The vertical asymptote in this graph is on the y-axis. As you can see, the given curves in the graph have arrows at their top ends, and these arrows suggest that the curves get closer to y-axis as we go up the y-axis. This is a very important concept we need to understand and memorize. So the vertical asymptote is at x equals 0. We write the equation of the vertical asymptote as x equals 0 because all points on this vertical asymptote have x value equal to 0. Next, we can analyze the horizontal asymptote or HA in this graph. As you can see in this graph, the curve in quadrant 2 has an arrow on its left end. The arrow suggests that the curve moves along the x-axis but doesn't touch it. Similarly, the curve in quadrant 1 has an arrow on its right end. The arrow suggests that the curve moves along the x-axis to the right side but doesn't touch it. So there is a horizontal asymptote on the x-axis. We write the equation of this horizontal asymptote as y equals 0 because all points on this asymptote line have y coordinate equal to 0. We have to use these asymptotes to write the domain and range for this graph. Let's start with the domain. As you may know, domain is a set of all possible x values for a function. We have to analyze the behavior of this graph along the x-axis. As we discussed earlier, the curves go all the way to the left side and the right side of the x-axis. But because of the vertical asymptote at x equals 0, 0 cannot be part of the domain because the curves do not touch the y-axis because there is a vertical asymptote on the y-axis. So we can write the domain in inequality notation as XER and x cannot be equal to 0. We can write this domain in interval notation as -infinity to 0 and 0 to infinity. We use round brackets for 0 because 0 is not part of the domain, and for -infinity and positive infinity we always use round brackets. This is the domain of the given function. Now we can write its range. As you may know, range is set of all possible y values for a function. We have to analyze the graph along the y-axis to find its range. As we can see in the given graph, the two curves do not go below the x-axis, and these curves do not touch the x-axis because there is a horizontal asymptote on the x-axis. Therefore, all possible y values for this function are values greater than 0. So we can write the range for this function in inequality notation as YER and y is greater than 0. So y can be all real numbers greater than 0. We can write this range in interval notation as 0 to positive infinity. We use round brackets for 0 because 0 is not part of the range, and for infinity we always use round brackets. This is the range in interval notation. This should be the final answer for range. So these are the steps you have to keep in mind to find the domain and range of this function. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.